Welcome to The Explainer. Today, we're diving straight into the actual physical building blocks of our modern world. I mean, think about it. Everything from the roads we drive on to the roof over your head completely relies on the construction materials industry. But how do we actually measure the true impact of creating these foundations? Well, let's unpack the industry standard that tracks exactly that. Seriously, just take a second and look around the room you're in right now. What did it actually take to build those walls, the windows, or even the foundation right beneath your feet? We kind of take our built environment for granted, don't we? But producing the materials surrounding us leaves a massive environmental, social, and financial footprint.
And this sector covers a really diverse range of products. We're explicitly talking about the manufacturing of cement and aggregates, the glass in your windows, plastic materials, the insulation keeping you warm, the bricks shaping your walls, and the roofing material right over your head. Producing these everyday objects at a global scale is just a colossal undertaking.
So, here's our roadmap for today. 1. Tracking the climate cost. 2. Managing water and waste. 3. Protecting workers and habitats. And 4. Innovating for the future.
All right, let's jump right into Section 1, Tracking the Climate Cost.
To track this massive climate cost, companies and investors rely on a specific blueprint, which is the SASB standards, now under the stewardship of the International Sustainability Standards Board. This acts as the authoritative tool to systematically track environmental and social impacts across the whole industry.
What we're looking at are the actual accounting tables straight from the standard itself. By breaking down these dense metrics, we can reveal exactly how this industry operates behind the scenes to measure what actually matters. Don't worry, we're going to make these manageable.
Right off the bat, the standard requires companies to measure their global Scope 1 emissions. Now, this isn't just some abstract carbon metric, right? This is the direct emission from firing up the massive kilns you need to make bricks, glass, and cement. These production facilities and their on-site fuel combustion generate a very real, very significant amount of greenhouse gases directly into the atmosphere.
So, to reduce those emissions, and honestly to save on energy costs, companies often turn to alternative fuels. Think things like scrap tires, spent solvents, or waste oils. But this is a massive industry trade-off. On one hand, yes, you reduce fossil fuel use. But on the other hand, burning these materials can emit dangerous air pollutants, specifically particulate matter like PM10, as well as nitrogen oxides and dioxins. So it really is a tightrope walk that requires careful monitoring to make sure there's an actual net environmental benefit.
Moving right along to Section 2, Managing Water and Waste.
You know, producing construction materials requires just staggering volumes of water. Because of that, this standard asks companies to calculate the percentage of their water that's withdrawn and consumed in regions with high baseline water stress. We define this as regions where water availability constraints and price volatility create a high operational risk. And this is fascinating, right? Because water scarcity isn't just an environmental issue here. If a quarry or a cement plant can't secure a stable water supply, production literally stops. That is a massive financial risk.
And then, well, there's the waste. Now, the industry actually does have high recycling rates, but the production process still generates a ton of challenging byproducts. The most significant waste category in the entire industry is cement kiln dust, or CKD. It's this fine-grained, highly alkaline solid waste that gets captured by air pollution control devices. Disclosing exactly how much of this waste is hazardous and how much is being properly recycled is absolutely vital. Because if you mismanage it, you're looking at massive regulatory fines.
Okay, so we've talked about the air, the water, and the waste. But what about the people actually extracting these materials from the earth? Let's pivot for a second and look at the human and ecological toll at the very start of this supply chain. Which brings us to Section 3, Protecting Workers and Habitats.
Before you can even bake a single brick or mix any cement, you got to get the raw materials. And quarrying involves removing topsoil and vegetation and physically blasting the underlying stone deposits. This permanently alters the landscape. Because of this, companies have to have incredibly strict environmental management plans in place. They need to track the terrestrial land area disturbed in hectares and, even more importantly, the percentage of that impacted area that actually gets restored to baseline habitats once the site closes.
On the human side, the hazards are, frankly, significant. And this is where the standard gets really specific about safety tracking. You see, companies can't just report on their direct employees, the people on their official payroll. They also have to track safety incident rates for contract employees, like independent contractors or temp labor managed by third parties.
This gives us a clear look at the industry's heavy reliance on third-party labor and ensures that literally everyone's safety is being monitored. And to track this safety fairly across companies of totally different sizes, the standard uses a very specific baseline number, 200,000. So when companies calculate their total recordable incident rate, or their near-miss frequency rate, they multiply their incident count by 200,000 and then divide it by the total hours worked. Why 200,000? Well, it perfectly represents the total number of hours 100 full-time workers would provide in a year, assuming they work 40 hours a week for 50 weeks. It just gives everyone a standardized baseline to compare safety data across the whole industry fairly.
Beyond just acute injuries, the standard also tracks chronic illnesses, most notably silicosis. Silicosis is a chronic lung disease caused by inhaling crystalline silica dust during the extraction and processing of these materials. Companies have to disclose the number of reported cases and detail their exact efforts to minimize worker exposure. This really underscores the crucial need for rigorous respirator programs and engineering controls to just keep that dangerous dust out of the air.
So, having looked at the environmental and human tolls of this industry, it really begs the question, can we build the future without destroying the present?
Let's explore that in Section 4, Innovating for the Future.
Both consumers and regulators are actively demanding greener buildings. Because of that, companies now track the percentage of their products that qualify for credits in Sustainable Building Design certifications. You've probably heard of some of these programs, like LEED, BREEAM, or Green Globes. Creating building materials like insulation, roofing, or glass that actually qualify for these certifications drives huge market demand. It proves that creating products requiring less energy or using recycled inputs directly increases a company's long-term competitiveness.
And the business potential here is absolutely staggering. The standard asks companies to look at the 100% total addressable market. Basically, this means calculating the potential revenue if a company were to capture 100% of the global market share for products that reduce energy, water, or material impacts. It shows investors the vast, completely untapped potential revenue for innovating green construction materials.
Finally, building the future also requires fair business practices, right? So the standard includes a metric for pricing integrity. This tracks the total monetary losses from legal proceedings associated with cartel activities, price fixing, and antitrust activities. Anti-competitive behavior completely disrupts the fair market and can result in massive legal fines. So strong corporate governance is really just as foundational as the physical materials being produced.
Well, we've covered a lot of ground today, from the intense heat of the kilns to the safety of the workers and the massive future of green innovation. It leaves us with one final provocative thought. As we design the skylines of tomorrow, are we holding our building blocks to a high enough standard? The framework is out there to measure the true cost of our modern world. Now, it's really up to companies and investors to actually use it.